Okay, 10.5 is the binomial theorem. This is a theorem about how to multiply binomials, raising binomials to positive integer powers. Binomial, two terms, right? So first, we need to learn about factorials. This is written 6 factorial, 6 exclamation mark. We read it as 6 factorial, okay? And what it means is 6 times 5 times 4 times 3 times 2 times 1. Now, of course, you can always leave off the times 1. But you're basically multiplying, starting at 6, going down an integer each time until you get to 1. Okay? 3 factorial, 3 times 2 times 1, etc. Okay? So hopefully that's pretty easy to understand. But there is one exception, which is 0 factorial. We need a 0 factorial for the binomial theorem, and so we have to define it to be something. It's not going to be 0 times every positive integer less than 0, which would be none. That would make it 0. We're going to actually be dividing by this, so we can't have that. But the number that works in our formulas is if we just assign it a value of 1. So 0 factorial doesn't follow the rule above. It doesn't follow any rule. 0 factorial is just, the only rule it follows is that it equals 1, okay? So just remember that, 0 factorial is 1, star by it. Now, we often do fractions of these things. In fact, we're gonna do a lot of fractions of these things. And so it's good to see how that works out. If I wrote this out, 6 times 5 times 4 times 3 times 2 times 1, over 3 times 2 times 1. Notice the 3 times 2 times 1 part repeats. So if you take a fraction of factorials, the smaller one will always cancel out completely with part of the larger one, because it always goes down through all of the integers until it gets to 1. So the 3, 2, 1 cancels off here. So what you end up getting is just, right, 6 times 5 times 4. Okay, just the first 3 factors of 6 factorial, which is 120. If I take 21 factorial over 16 factorial, all I have to do is start at 21 and write out products with each integer going down 1. And I need to write out 5 factors. How do I know it's 5 factors? Because 16 of the factors will cancel out. 16 times 15 times 14 times 13 times 12, etc. That's 16 factors. Those will all cancel out. 21 has 21 factors in it. So I've canceled out 16 of them, so it's left with the 5 largest factors. 21 minus 16 is 5. So I just had the 5 largest factors. So this saves us a lot of computation and a lot of writing. It's just 21 times 20 times 19 times 18 times 17. That's still a fairly large number. It's 2 million something. 2,441,880. Okay, so binomial coefficients are written this way. This is read 15 choose 3. Now, it's not a fraction. It's not 15 over 3, like with a divide sign. It is over it, but it's not a divide sign. So we say 15 choose 3. What it means is this is the number of ways that if you had 15 objects, say you had 15 people in a classroom, and you chose 3 of them at random, this is how many different ways that could be done. So say you said, okay, 3 of you are going to go to a conference in Washington, D.C. And I don't care which one goes, so we're just going to draw names out of a hat. The number of different groups of 3 that you could have go is 15 choose 3. You have 15 people and you're choosing 3 to go to Washington. That's why it's called 15 choose 3, okay? So it has to do with probabilities and stuff. counting and something called combinatorics, which is counting the number of ways that something can happen using clever formulas and stuff. Okay, so this you can compute. You don't have to write out all 15 students on a board, like all their names, and then try to figure out how many ways you can group them into threes the hard way. You can just use this formula. So it's 15 factorial over 3 factorial times 12 factorial. Notice 3 plus 12 is 15. That's where that 12 came from. The 15 came from over on the left, right? The 15 comes from here. The 3 comes from here. Where's the 12 come from? Well, 12 plus 3 is 15. We say that 12 is the complement of 3 in 15. It means if you have a set with 15 objects, you can divide it into 3 objects and 12. In my example of sending people to Washington, if you're sending 3 people to Washington, you're choosing to send 3 people to Washington. That's the same thing as choosing 12 people to not go to Washington. And that's kind of where this 12 comes from. Okay? In a loose sort of sense. That formula you need to know. Not that one. This. You know that 3 plus 12 is 15. This formula you need to know. That you need to know. Okay? How to do this you need to know. We do this to compute these if you're going to do them by hand. Okay? So 12 is called the complement of 3 in 15. And also 3 is the complement of 12 in 15. So 12 and 3 are complements of each other in 15. It just means if you have a set of 15 objects and you split it into 2 pieces, one with 3 in it, then the other one is 12. It's a set. Complement is a term used when you're talking about sets. It's like everything outside of a set. So outside of the set of 3, but inside the 15 is 12 objects. 12 numbers in this case. It works like that. This graphical representation. So for example, 15 choose 3, right? My example. Notice that is the same as 15 choose 12. So that's what I was saying. If you choose 3 people to go to Washington, you're choosing 12 people to stay. Kind of the same thing. As long as you know that 3 people actually go. So in general, n choose k is n factorial over k factorial times n minus k factorial. This looks more complicated, but remember, you'll have specific numbers for n and k, and it just works like the 15-3 example. Now, remember, if that 3 is a 0, then this 3 factorial would be a 0 factorial. That's 1, not 0. That's important. You don't want to divide by 0. And then its complement would be 15. So you'd have 15 factorial over 15 factorial, which is 1. So 15 choose 0 is 1. Why would that be? How many ways can you choose nobody out of 15? Well, there's only one way. You just don't choose anybody. Right? Anyway, so that's the binomial coefficients. Those are used for a lot of things in math.